So now let's take the 4 kilogram object on an inclined plane, 35 degrees. And now let's hang a string over a pulley with over a hanging mass, and let's ask a couple questions here. A, what does M need to be so that system doesn't accelerate? Okay, and then B, if M is 1 kilogram more than this, what is the acceleration of the system? And then C, if M is 1 kilogram less than this, what is the A of the system? Okay, so this one we can do equation for each one. So we've got the M here. We have mg and the tension in the rope. See, they're connected with over rope or string. There's a tension here, and that tension is propagated throughout the length of the string, and the tension pulls up on the lower block, on the 4 kilogram block. The tension in the string always pulls, it never pushes. It pulls both objects. So for this block you have mg is T, and for this block you've got you see 49.8 cosine 35. So when I put this, when I'm going to draw the forces, I'm already going to put the y component of the force, the perpendicular component of the weight, and the horizontal component of the weight is what? 4 times 9.8 times sine 35. And you don't even have to draw the total weight, you know. So you have so those are the forces right there. Now, one interesting thing about these kinds of problems is that for this guy, I can have a regular xy axis. And then for this guy, I can have a rotated xy axis. I don't need to have the same xy axis. So for this guy, I'm going to do x prime, y prime. And then for that guy, I'm going to do xy. And I can still do the problem that way. One regular xy, one x prime, y prime. Doesn't matter. So in part A, it says, what does M need to be so a system doesn't accelerate? So as long as this equals that, this thing doesn't accelerate. Okay. And then as long as T equals this guy right here, it doesn't accelerate as well. And we know N is already going to equal 4 times 9.8 cos 35. So that one is a given. Right? So all we need to do is just set these two equal. T equals 4 times 9.8 times sine 35. So now we already know the T must be equal to that, and then mg needs to equal T. So therefore mg needs to equal this. So we can set these two equal to each other. And then the 9.8, 9.8 cancel. So therefore, the mass that you need over there is equal to whatever this is times its sine of the angle, the downward component of the weight, right? As long as that equals 4 times sine, then the system doesn't move. Okay, so what is that there? Give me 2 decimal places. Three point. 2.29. Okay. Which makes sense. 2.29 kilograms. If this is 2.29 kilograms, it can match a 4 kilograms sitting on the inclined plane. That makes sense? We knew the answer has to be less than 4, right? You don't need 4 to match a 4 sitting on the incline. You need less than 4, right?
How do you know the tensions are the same?
The tensions are the same, good question, because we are actually ignoring the mass of the pulley. When we get to chapter 10, and when we do rotational motion, we're going to talk about moment of inertia. Then you're going to see that the tension on this one here is going to be a little more than the tension there, if you want it to accelerate this way. So if the pulley actually has some mass, then the tensions are not always the same. But in this chapter, we are ignoring the mass, ignoring mass of pulley. Therefore, it's like as if there is just one string connected over a pulley, and it's the same string, you know. So that's why it has the same tension. Okay, so now 2.29. So now with part B, if M equals 1 kilogram more than this, what is the A of the system? So now we're going to put 3.29 kilogram, right? 3.29 kilogram here. What happens here? So we have this thing is going to be 3.29. Well, it's going to accelerate down, right? Because it's going to beat the 4. So now we have the acceleration of the system is down. So remember the elevator problem. How I do this is, if the A is down, this one wins that one. I put this one first. I put this as positive, then I put this one as negative. So 3.29 times 9.8 minus T equals 3.29A. And let's see. Okay, now we need the equation for this guy. What's going to happen to this guy? This one is going to accelerate up, right? If that accelerates down, this one is going to accelerate up. So the T is going to beat the 4 times 9.8 times sine of 35. The T has to beat that, right? So the equation for that is going to be T minus 4 times 9.8 times sine 35 equals what? What times A? Its mass times A, right? And its mass, well, it's a good idea to always put the mass right inside of the box there. Its mass is 4. So